6?
Nope.
Yeah. We're just going to jump in here.
When are we going to be done with this chapter? This chapter is awful.
You don't like it?
Nope.
Okay, so hush. Okay, this problem, we did one of these or two of these on the worksheet. It combines multiplying with, what kind of problem is this when you do two terms? Foil. These are FOIL problems. Do you guys remember what happened when we FOIL like something like x plus 5 times x minus 5?
It would be x squared minus 5x.
Minus 5x plus 5x. So what happens when you multiply, and then these two are, the last two are negative 5 times 5 is negative 25. So when they're almost identical except for one has a plus and one has a minus in the middle terms cancel out. And you just get like x squared minus 25. So these are called conjugates because something special happens when you multiply them. The middle terms cancel out, and that's what number 1 is. Number 1 is a conjugate. You can FOIL the whole thing, but you can also just do the first and the last because the outside inside will end up canceling out. Because this is our first one, I'm going to go ahead and FOIL the whole thing. I'm going to go ahead and multiply all of it. So F in the FOIL stands for first. So what's 2 times 2? 4. O, the outside, the ones that are far away, is 2, positive 2 times positive square root of 3. What's 2 times square root of 3? 2 square root of 3. Okay, the inside, I, is 2 times negative square root of 3. So it's negative 2 square root of 3. And the last is negative square root of 3 times positive square root of 3. What's square root of 3 times square root of 3?
Square root of 9.
Which is 3. Square root of 9, which is 3. Remember, anytime you take a square root times itself, let's get that out of there, it just becomes a normal number. So, but one of them was negative, so negative square root of 3 times square root of 3 is negative 3. Okay, what's going to happen to our middle terms? Cancel. Because these two are conjugates, they're like almost identical, that's going to happen. 2 square root of 3 minus 2 square root of 3 is 0. But we still have 4 minus 3. So, yeah, number 1 is just 1.
That's funny. Thanks, Jackson. That's the funny smell. Oh my.
Number 1 is 1.
Yeah,
Okay, number 3, are these conjugates? Is this like number 1?
Yes.
Yes. So I'm going to cheat on this one. I'm just going to do, because I know the outside inside is going to cancel out, I'm just going to do the first and the last. So on the FOIL, I'm going to kind of skip those two. Just going to do the first and the last. So what is square root of 3 times square root of 3?
Square root of 3. But 3. Just regular.
Square root of 9, which is 3. Square root of 3 times square root of 3 is 3. Yeah, if this confuses you, by the way, you can still go ahead and do the whole FOIL. It's just extra. But then the last, what's negative square root of 3 times, or sorry, negative square root of 11 times square root of 11? Square root of 11 times square root of 11 is
Negative
11, but because one of them's negative, it's negative 11. So this is just 3 minus 11, negative 8.
So why would you do the middle two?
Because they cancel out when they're conjugates. Number 5. How do we do square root of 5 minus square root of 3 squared? What does that mean?
Just write it twice.
Yeah, you write it twice. You guys remember that from foiling? You can't just square this and square this. You have to take all of it times all of it. So it is a FOIL problem. You have to do 2 of these multiplied together. Are these conjugates? Is this like 1 and 3? No, because they're both minuses, so the middle terms will not cancel out. We do have to do the whole FOIL on these. Okay, so start with the first. What's square root of 5 times square root of 5?
Square root of 5. Just root of 5, right?
Okay, square root of 5 times square root of 5 is
25.
square root of
But it'd be
25.
5.
5. Anytime you take a square root times itself, this becomes a normal number. Okay, and then the outside, what's square root of 5 times negative square root of 3? Well, there's one negative, so it's negative square root of 15. Does square root of 15 simplify? No. The only thing that goes into 15 is 5 and 3. It has to have a double to simplify. Okay, the inside is the same. It's negative square root of 3 times square root of 5, so it's negative square root of 15. Are those going to cancel out? No. It's like negative 1 of these minus 1 of these. Negative 1 minus 1 does not cancel out. It's negative 2. Alright, anyway, then we have negative square root of 3 times negative square root of 3. So that's positive 3, yes. So plus 3. Alright, then we add our like terms together. 5 plus 3 is, I'll put it over here, 8. And then negative square root of 15, or you could say negative 1 square root of 15, minus 1 square root of 15, right, is negative 2 square root of 15. It's kind of like negative x minus x, this is negative 2x. Same idea.
Wow, that's cool.
Okay, number 7. 7 plus square root of 3. Okay, these are definitely not conjugates. Just like 1 through 4, I guess. No, never mind. Number 4 is not. Okay, 7 plus square root of 3, 4 minus square root of 11. Alright. Brianna, do you know what we should do first? When we FOIL? Well, first you should do the F first. So what are the first in these two? Right. So 7 times 4 is 28. I'll do the calculator part, okay? What's this stand for? Outside. So what are the outside two? Yep. So 7 times negative square root of 11 is negative. Multiply with one negative. And they don't really mix. So it's just 7 square root of 11. 7 times square root of 11. Okay, do you know what the I stands for? Or what we do next? If this is outside, inside. So 4 times square root of 3 doesn't really do anything, so it's just 4 square root of 3. And then what's the L stand for? First? Last. By last we mean the last in the parentheses, so that would be these two. So square root of 3 times negative square root of 11 is negative square root of 3 times 11, 32. When the answer's like this, your calculator can't do it because even good calculators can only spit out 2 terms. Do any of these terms simplify? Like, can we add any together? No, they're all different. So your calculator spit out a decimal. Don't write the decimal down. I'm not going to give you credit for it. So, 33 is like 3 times 11. Anyway, none of this simplifies. So that's as good as we can do.
That's a big answer.
Yeah, it's not very simple. Yeah, number 8's like that. 8 and 9.
Yeah.
Oh man. Okay, oh, I'm on the wrong one. Okay, square root of 6 minus square root of 2. Whoa, whoa. Before we even multiply this one, there is something that I do notice that's a little bit different. Do you guys notice anything about this one? Before we FOIL? Square root of 8 does simplify because there's some double 2's in there. I think I'll actually, and we could do that at the beginning, but I think I'll actually not simplify it until we get to the end, probably. So we'll just do that at the end. Mallory, what should we do first on this? Yeah, square root of 6 times square root of 8, so that would be square root of 48. Okay, that's going to simplify. But we'll do that, we'll get to that later. Okay, then what? Okay, that does not simplify, so it's just 4 square root of 6. Then what? Right, negative times a positive is negative. Negative 2 times 8 is square root of 2 times square root of 8, square root of 16. That definitely simplifies, right? And then what's the last thing we do? So that would be negative 4 square root of 2. Alright, so 48 definitely has some doubles in it. Right? Does 6 have any doubles in it? No, it just has 3 times 2. So 48 is 6 times 8. There's a lot of 2's inside of it. So what comes out is 2 times 2.
And the 3 would be left behind.
Right, and the 3 gets left behind. Okay, this guy is as simple as he gets. So I'm just going to copy him down. What about square root of 16? That's just 4. You don't really have to do the tree. You could do the tree. Okay, 2 2's come out. It's just a 4. Square root of 16 is just 4. Alright. And that doesn't simplify. Is there anything else we can do here? No. So it's kind of like number 7. There's not a lot. Lots of 4's on that one. Okay, 11 and 12, these are super fast. We're just supposed to write what is the conjugate of this. You guys know what it would be?
Positive 3.
No, it's just the sign in the middle that switches. So it's just negative 3 minus square root of 5.
What are conjugates?
Conjugates are things like number 1. When you multiply them together, the outside inside cancel out. Okay. Before I do 13, let me back up a little bit. One of the really hard assignments we did was division with square roots. You guys remember that? a couple weeks ago. So this does not divide, even if this was like a 10 or something, that does not divide. If it was a square root of 10, yeah, that would be square root of 2. But this doesn't divide, but you can't leave the square root in the denominator. Remember how we fixed it? We multiply top and bottom by the denominator. Because that keeps the value of the fraction the same when you multiply the top and bottom. And what's square root of 5 times square root of 5?
5.
And 10 times square root of 5 doesn't really do anything. But now since these are both normal numbers, you can divide those. 10 divided by 5 is 2. So this is 2 times square root of 5. Yeah. So 13 says 1. Okay. This does not divide at all. But they don't like it when you have a square root in the denominator. But this time I can't just multiply by square root of 3 because you'd have to multiply the whole thing by square root of 3. And you get like 2 square root of 3 plus 3. So you'd still have a square root on the bottom.
Could you flip?
So what you have to do is multiply not by square root of 3, you have to multiply by the conjugate, 2 minus square root of 3. But if you do that to the bottom, you have to do the same thing to the top. So, on the top, what is 1 times 2 minus square root of 3? Well, it doesn't really, multiplying by 1 doesn't do anything. So the top is just 2 minus square root of 3. On the bottom, it's a FOIL problem, but because they are conjugates, all we really have to do, like number 1, number 3, those problems, all we really have to do is multiply the first and the last. If we multiply the outside and inside, we could, but they would cancel out. So really, we only need to do the first and the last. So the first, I should have just written it up here. Okay, the first is 2 times 2, 4. And the last is square root of 3 times negative square root of 3.
-3.
Negative 3. So we just have 4 minus 3 on the bottom, which is 1. And what happens when you divide by 1? Well, nothing happens. Like multiplying by 1, it just kind of does nothing. So, this would just be 2 minus square root of 3. Simple as we can get it. If the 1 had been something else like a 3 or a 5, whatever, if this had been a different number, we would have just left it there. Nothing you can really do. Okay. Number 15. Square root of 11. Okay, again, these do not divide. This is square root of 3 plus square root of 2 is a really weird number. There's no way it would simplify with dividing by square root of 11. These don't add together either. There's just nothing we can do here. But we're not supposed to leave square roots on the bottom. So guess what I'm going to do? I'm going to multiply by the conjugate. Square root of 3 minus square root of 2. On the top and the bottom. On the top, how do I multiply this together? What kind of problem would this be if I did this times that? It'd be distribute. Square root of 11 times square root of 3 is square root of 33 minus square root of 11 times square root of 2 square root of 22. These don't simplify. There's nothing we can do with these. This is just 3 times 11. There's no doubles. 2 times 11. No doubles. They definitely don't subtract. So that's all we can do. Now what am I going to do on the bottom? It's kind of a FOIL problem, but since they're conjugates, I'm only going to do the first and the last. So the first is square root of 3 times square root of 3. 3. And the last is square root of 2 times negative square root of 2 minus 2. Okay, so we got another 1 on the bottom. That's not going to happen every time. Kind of unfortunate, really. But if there's a 1 on the denominator, it kind of just goes away. So it's just the numerator.
Which one is this?
It's secret. On 18, you could multiply by the conjugate, but what's square root of 4? 2. So what does 2 squared root of 4 turn into? Yeah, turns into 2 times 2, which is 4. Plus 1 is 5, so the denominator is just a 5. So there's no square root. So you don't, and it doesn't divide. So you just kind of simplify. 18, you simplify the denominator on that one. You don't really have to do the whole conjugate thing. 17. 17 is going back to a couple weeks ago. If there's just one term on the bottom, you just multiply by square root of 2. Multiply it by itself. So the top is 1 times square root of 2. Square root of 2. The bottom is square root of 2 times square root of 2. Which is just normal 2. And that's all she wrote. I think they were just trying to remind you of like last time. Did I say 20? Yeah.
Why would you multiply 2 and 1 since it's not in the box? They're not in a
Okay, you could say it's 1 square root of 2,
Oh.
but you just don't need, it's like saying 1x, you don't really need a 1 in front of it. But if you put 1 square root of 2, it's not wrong. It's just not necessary. All right. I think I'm going to make 20 bonus, but let's do 19. 20 is just large. But if you remember a bunch of stuff we learned this year, you can still do it. 19 is a little bit easier. Okay, when you're multiplying stuff together, does the order of multiplication matter? No. Like 2 times 3 times 4 equals 4 times 3 times 2, or whatever. So, if that is true, can I multiply this and this first? The answer is yes. Why would I multiply those two first? Because they're conjugates and they're easier to multiply. And when they're conjugates, you only have to do first and last. So, square root of 5 times square root of 5 is square root of 25, which is 5. And then on the outside, so I'm kind of ignoring this, or the last, it's negative 3 times 3 minus 9. So that's just negative 4. So, but we still have to multiply that thing. So it's negative 4 times that thing. So now it's actually just distribute. Number 20 is a lot harder than 19 is. And the answer is a lot messier too.
Where did you get the 5 from at the beginning?
I multiplied these two together, like foiled these two.
Yeah, we should put it off.
Square root of 5 times square root of 5. So, right there.
So it's 319.
20, there is no conjugate, so you'd have to FOIL something, and then you have to multiply that by another thing. It's pretty tough. If you want some help on that, I'll give you a little bit of hint. But